Hello all, welcome to Tangola online classes. In this session, we'll continue LCR series circuit, the continued part of LCR series circuit in detail we'll see. Continued part mean here we'll see the concept of electric resonance and concept of Q factor. That those concepts we'll see in detail. See here. We know that in the last class already we have learned that when inductor, capacitor and resistor all are connected in series combination, net opposition offered by capacitor, inductor and resistor to flow of AC, that we are calling electric, that we are calling impedance of LCR circuit. But taking impedance of LCR circuit, we will see what is meaning of electric resonance. Electric resonance only resemble to LCR series circuit. Before that, last class what we have obtained? See here, inductor, capacitor and resistor are connected in series combination. Inductor, capacitor and resistor are connected in series combination. Those series combination is applied by particular AC voltage. Look at this particular AC voltage. What you can see, this we are calling inductor of inductance L, this capacitor as capacitance C and resistor has resistance R value, right? And this is applied alternating voltage. What is applied alternating voltage? That V is equal to V naught sine omega into T. This we obtain, right? See here, from this opposition offered by inductor to flow of AC, this we can call inductive reactance. Inductive reactance. What is inductive reactance as value? XL is equal to omega into L, right? Opposition offered by capacitor to flow of AC, this we are calling capacitive reactance. Capacitive reactance can be represented by what quantity? Capacitive reactance can be represented by omega into C. Okay. Now opposition offered by resistance to flow of AC, what you are taking? R is equal to what value? R is equal to V divided by I. Right. See here, net opposition offered by inductor, capacitor and resistor to flow of AC, that we are calling inductance, that we are calling impedance of LCR circuit. What is impedance value? Z is equal to how much we obtain? Z is equal to under root of how much? Under root of R square plus XL minus XC whole square. What this is? Opposition offered by inductor, capacitor and resistance to flow of AC, this we are calling impedance of LCR circuit. See here, this quantity. From this quantity we can obtain how much amount of current can flow. We know that according to Ohm's law, V is equal to I into Z. Last class we replace. What is I value? I is equal to how much? V divided by Z. Right around this. We know that when current is maximum here, wherever Z value should be decreased, then I value is maximum, because I and Z both are reciprocal to each other here. Wherever Z decrease, I should be increase. To increase the I, what we do? Z value should be decreased. Z value decrease mean here what happens? Z value decrease mean if inductive reactance equal to capacitive reactance, then Z is equal to R here. See here, shall I take here? What is condition for resonance here? If the case inductive reactance equal to capacitive reactance, inductive reactance equal to capacitive reactance, if XL is equal to XC, then what you can take? Z is equal to R. Z is equal to R. If Z is equal to R, then from this equation what you can take? I is equal to V divided by R. This is condition for maximum current. Here what is electric resonance? When alternating voltage of particular frequency applied to LCR series circuit, current in LCR circuit is maximum. This phenomena we are calling electric resonance. What is meaning of electric resonance? When an alternating voltage of particular frequency applied to inductor, capacitor and resistance, then current in circuit is maximum, that we are calling electric resonance of LCR series circuit. To get maximum value of current or to get electric resonance, what is condition? Condition must be inductive reactance equal to capacitive reactance. Wherever inductive reactance equal to capacitive reactance, then only current in circuit is maximum. This phenomena I can call electric resonance. Right around this. Then at a particular frequency, current in circuit is maximum. What particular frequency required? That we'll see. See here. Our next concept I can go expression for resonant frequency. I mean at a particular frequency of alternating current, at a particular frequency of applied voltage, current in circuit is maximum. See here. Now our next concept is what is meaning of resonant frequency and what is its expression. That we'll see. Very simple. Expression for resonant frequency. Expression for resonant frequency. Expression for resonant frequency, that we'll see. In simple manner I can take. See here. Electric resonance mean when inductive reactance equal to capacitive reactance, current in circuit is maximum, that we are calling electric resonance simply. Or in alternating way, how to define? When an alternating voltage of particular frequency applied, a current in LCR circuit is maximum. This phenomena we are calling electric resonance. See here. At electric resonance, what is condition? Condition must be inductive reactance equal to capacitive reactance. Then I can call V is equal to I into R, because Z is equal to R here. Z is equal to R directly. Right. Then XL, we know XL is equal to omega L. For my reference, I will take resonance frequency is omega R. At this frequency, current in circuit is maximum. R. What is XC? XC is equal to omega into C. Omega can replace by omega R. Omega represents resonant frequency. Then just rearrange this value. Rearrange mean I can take omega R whole square is equal to what value? 1 by LC. Or what is omega R? Omega R is equal to under root of how much? Under root of LC. This I can call angular resonant frequency. At this frequency, current in circuit is maximum. At this frequency, current in circuit is maximum. We know that when inductor, capacitor has a definite value, at a particular frequency, current in circuit is maximum. At this frequency, current in circuit is maximum. What current available? This much current available. Where I can take here Z is equal to R, I mean I is equal to what value? V divided by R. This I can call maximum current. Right? This is angular resonant frequency. If I take linear resonant frequency, then how to take? See here, very simple. Omega is equal to how much? Omega is equal to 2 pi into F is equal to how much? 1 divided by root LC. Or what is F value from this again? F value is equal to 1 divided by 2 pi under root of LC. This is the linear resonant frequency. This I can call linear resonant frequency. This I can call angular resonant frequency. But your point is, at a particular frequency, current in LCR circuit is maximum. Experimentally, if we plot the graph of frequency versus current, how the graph comes? See here. Along x-axis, I will take frequency. Along y-axis, we will take current. Look at this is current and this I can call frequency. Frequency either you can take linear frequency or angular frequency, no matter. At this frequency, we know that when a particular frequency applied to LCR series circuit, current in circuit is maximum. If you plot the graph of frequency versus current, the graph must be like this. Graph must be like this. See here. At this frequency, say I can call this frequency is omega R. At this frequency, current in circuit is maximum. This value I can call peak value. Say it is nothing but I naught. At this frequency, current in circuit is maximum. This frequency I can call angular frequency, and this current I can call maximum current. This you can call peak value of current. Already we know peak value of current. Meaning of this is maximum value of current. This you can call peak value of the current. Then question is, at a particular frequency we got maximum current. Definitely we got maximum current. But see here, at the same current we are getting two different frequencies. Look at this graph. At this graph, at the same current we are getting two different frequencies. How it is? See here, I can take this point. At this current, say this current is I. At this current, say this much frequency available. This frequency I can call omega 1. And look at the same current, we are getting one more frequency. This frequency is equal to omega 2. At the same current I, we are getting two different frequencies, say omega 1 and omega 2. Where this difference omega 1 and omega r, how much difference available? D omega available. Again in between omega r and omega 2, again this much difference available. Right? Are you following this graph? How the graph follows? At the same value of current I, what we got? At same value of the current we got two different frequency, omega 1 and omega 2. On this basis, I can define one more physical quantity. That physical quantity is Q value of LCR circuit. Q factor of LCR circuit. See here. Meaning of Q factor we will see. What is meaning of Q factor of LCR series circuit? See here. Q factor of LCR circuit I can define the ratio of resonant frequency to bandwidth. How to define? The ratio of resonant frequency divided by bandwidth, that represent Q factor of LCR circuit. Bandwidth means difference in frequency, say omega 1 and omega 2. That we are calling bandwidth. See here, alternating way I can define. What is Q factor here? Q factor is the ratio of resonant frequency. Resonant frequency, say omega r. What is bandwidth? Bandwidth is equal to omega 1 minus omega 2. This is Q factor. Right? Q factor is ratio of resonant frequency to bandwidth. Now let us see how the Q factor comes and what is its expression. Our aim is expression for Q factor of LCR series circuit. That we will see. See here. Shall I repeat? Remember this concept? How graph becomes as a function of frequency, as a function of current, when inductive reactance equal to capacitive reactance. I mean resonance of LCR series circuit. See here. Our next concept is expression for Q factor. Okay. Let us take Q factor, expression for Q factor. Q factor, in detail we will see. Let us take its expression. See here. Directly you can take expression for Q factor. Expression for Q factor. Q factor. See here. This we'll see in detail. Before that, at resonance, how the graph was there, that we'll see. How the graph was there at resonance, electric resonance. Like this symbol. Say this is current. This is frequency. Say I can call this frequency nothing but omega. How the graph was there? Graph must be like this. Right? We know that at this frequency, current in circuit is maximum, say frequency omega r. What about this current? This current is equal to how much? This current is equal to I naught. Right? At two different frequencies, same amount of current available here. How about I can take this value is nothing but I value. Say this I, at I, what frequency available? At I, omega 1 available. And at I, omega 2 available. Two different frequency are available. Are you following me? Then, what about in between omega 1 and omega r? This much difference available, say d omega. Here also d omega available. In between omega r and omega 2. Right? Now, here what is meaning of omega 1, what is meaning of omega 2, that we'll see. See, before that, shall I write expression for Q factor? Definition of Q factor. What is definition of Q factor? Ratio of angular frequency divided by bandwidth. Bandwidth is equal to omega 1 minus omega 2. This is called Q factor. Let us take this Q factor is equal to 1. Right? We know this omega 1. What is omega 1? Omega 1 is equal to d omega plus omega r. Omega 1 is equal to omega r plus d omega. Either you can write d omega plus omega r, omega r plus d omega, no matter. Similarly, omega 2 I need. What is omega 2? Omega 2 is equal to omega r minus d omega. Omega 2 is equal to omega r minus d omega. Remember this point? But we know current here. What is current formula? Current is equal to how much? Current is equal to V divided by Z. V is equal to I into Z. Right? At resonance, what is current? At resonance, maximum current available. At resonance, maximum current available. We know that at resonance, what is formula? At resonance, formula is what value? I naught into R value. At resonance, because at resonance maximum current available, at resonance Z is equal to R value. Z is equal to R value. Remember this point. So I am putting V is equal to I naught into Z. And what is Z value? Z value is equal to under root of how much? Remember this formula. I will put later. So shall I take then from this? I is equal to how much? I naught into R whole divided by Z. Right? Remember this, but we know this current is nothing but RMS current. This current is peak current, this value resistance, this value what we are calling impedance. Look at me. In between peak value and RMS value, we know relation. See here. We know relation I is equal to I naught by root 2 because V is equal to V naught by root 2, E is equal to E naught by root 2 like this. Then I naught keep it up same, R also keep it up same. What is Z value? Z value is equal to under root of R square plus XL minus XC whole square. Right? Look at me this. Then this I naught get cancelled. What is remaining here? 1 divided by root 2 is equal to R divided by under root of how much? Under root of R square plus XL minus XC whole square. Right, think this, or else root 2 into R, root 2 into R is equal to under root of R square plus XL minus XC whole square under root. Are you following me? Then see here, just square on both sides, what will get? Look at me, just square on both sides, squaring mean, so under root 2 becomes 2, R becomes R square is equal to under root of this value how much? R square plus XL minus XC whole square. But we know XL. Look at me this formula. Shall I simplify this? 2R square minus R square, that becomes R square. R square. Right? XL replaced by what value? Omega into L. XC can be replaced by what value? Omega into C. Of what value? Whole square. But I will take omega 1 here, omega 1. Look at me. Shall I take here omega 1 on both sides? By taking one only we will solve. Again you will take square on both sides. Square on both sides mean what we will take? Square root on both sides. Square root on both sides mean R square becomes R value. Right. Omega 1 into L minus of how much? 1 by omega 1 into C. But we know omega formula. What is omega 1? Omega R plus d omega. Write this. Just put here. R is equal to omega 1 mean how much? omega r plus d omega of L value, 1 divided by omega r plus d omega of how much? That is C. Right or wrong this? Now I can modify this value. How to modify? Look at, in this way I can modify. R value is equal to omega r into bracket 1 plus d omega divided by omega r. Just I can put this value. If we simplify this step, above step will come. How it is? Omega r plus d omega divided by omega r. This omega cancel. I can replace this step as in this way. Right? Similar this step I want to put. 1 minus, similarly this one. How to put this value? 1 divided by omega r. 1 plus d omega divided by omega r into how much? C. Into C like this. This step I want to bring in upper side. What will get? R is equal to omega into r. Omega into r into L, keep it up same. Into bracket 1 plus d omega divided by omega r. Are you following me? Minus of 1 plus d omega divided by omega r. I will bring in upside. What it becomes? See here. 1 plus d omega divided by omega r. I will bring in upper side. It becomes minus 1 whole divided by how much? Omega r into C. Are you following this? Are you following me this step? See here. Or can solve according to binomial theorem. 1 plus d omega divided by omega raised to minus 1. How it becomes? Look at me here. R is equal to omega into L into bracket 1 plus d omega divided by omega r minus, see here, 1 minus d omega divided by omega r whole divided by how much? Omega r into C. Are you following me this step? So I can simplify. Look at me. This step again I need to simplify. See here, I will simplify here. Just I will remove this, or I can simplify here also. See here. In what I can replace? Look at me this value. R is equal to how much? Omega into R. Keep it up same. L also keep it up same. 1 plus d omega divided by omega r, keep it up same. Look at this value. This value I can replace. In what way? We know this formula. How much it is? Omega r is equal to 1 divided by LC, under root of LC, resonant frequency. Omega square is equal to how much? Omega square is equal to how much? Omega square is equal to 1 divided by LC. Or what is C? C is equal to how much? 1 divided by omega square into L. What is C value? C value is equal to 1 by omega square into L. Remember this formula. C value just I want to replace. See here. C value is equal to 1 by omega square into L. Look at me here. Minus of how much? 1 minus d omega divided by omega r whole divided by, see here, omega r keep it up same. C value 1 by omega square into L. See here, I want to solve this step here only. Look at me. Shall I remove this? Look at me. Just I want to remove it. I will solve here. In what I can get? Look at this step. R is equal to what we got? R is equal to how much? R is equal to omega into R into L into bracket 1 plus d omega divided by omega r. This value minus 1 minus d omega whole divided by omega r whole divided by omega r, keep it up same. Omega r, keep it up same. What is C? C is equal to 1 by omega square into L. C can be replaced by what value? 1 divided by omega square into L. Right? This goes upside. Shall I put one more step here? Look at me. I will cut here only one step. C is equal to 1 by omega square into L. Right? Like this. C is equal to 1 by omega square into L. Then here 1 omega r, 1 omega r get cancelled. What is remaining directly? What will take? R is equal to omega r into L into bracket 1 plus d omega divided by omega r. Omega r. Right? What it becomes then? Omega RL is remaining. Omega r into L into bracket 1 minus d omega divided by omega r. Are you following this? Just I will do omega RL is common on both sides. What I will take then? R is equal to omega r into L is common. What is remaining then? 1 plus d omega divided by omega r. Right? Minus of how much? Here minus is there. Minus of how much? 1 minus d omega divided by omega r. Bracket complete. Right? Just I want to open this bracket. If you open this bracket, minus becomes plus value. In what we can take again? R is equal to omega r into L. See here how it becomes then? 1 plus d omega divided by omega r divided by omega into r minus 1 plus d omega divided by omega into r. Are you following me this? I open this bracket. Minus 1 plus 1 get cancelled. Right? Then what it becomes? D omega divided by omega, d omega divided by d omega r. What it becomes? R is equal to omega r into L into how much? 2d omega divided by omega into r. Right? Omega cancel. Then what is remaining? R is equal to L into 2d omega. Right? Or from this, what is 2d omega? 2d omega is equal to r by L. 2d omega is equal to r by L. Right? Remember this one. We got Q factor. Expression for Q factor. Earlier we obtained. What is Q factor here? Q factor is equal to what value? Resonant frequency divided by bandwidth. Bandwidth was a 2d omega. Earlier we obtained 2d omega. But 2d omega is equal to r by L. Simply I can put this value then. What is Q factor? Q factor is equal to omega r divided by 2d omega is equal to r by L. R by L. L goes upside. Then what we got? Q factor is equal to omega r into L divided by what value? R value. This what we are calling? Simply I can call this as Q factor expression. See here, I can explain this Q factor here only. Look at me. What do you obtain the equation? Q factor is equal to omega into r into L divided by how much? This value r. So omega r into L, this you can call inductive reactance again. This Q factor simply ratio of inductive reactance divided by resonance, that is XL divided by R I can define, or ratio of angular frequency to ratio of resonant frequency to bandwidth. Ratio of resonant frequency to bandwidth, this you can call Q factor. Again, remaining concept concerned to LCR series circuit, we will see in the next session. Thank you.